Good evening, ladies and gentlemen. On behalf of the Connecticut Department of Transportation and the town of Wilton, it is my pleasure to welcome you for attending this virtual public informational meeting for Project 161-143, replacement of bridge number 05501, Arrowhead Road over the Norwalk River in the town of Wilton. My name is Preeti Bardwaj, Project Manager for the department, and I am joined here this evening by my design team and Mr. Frank Smariglio, Assistant Planning Director for the town of Wilton, to discuss the replacement of the Arrowhead Bridge. The Arrowhead Bridge is owned by the town of Wilton and provides the only ingress and egress for this residential neighborhood. The town and the department are presenting the proposed preliminary design for this bridge in joint partnership because it is funded under the department's federal local bridge program. And we hope that you will find this virtual public informational meeting both interesting and informative. I would like to go over the agenda and format for tonight's meeting. I will explain how you will be able to interact with the project team. I will explain how this project is being funded in the Federal Local Bridge DMS or Design Managed by the State program. We will be having some welcoming remarks by Mr. Frank Smariglio from the town of Wilton. I will then be introducing the project design team that includes the department's front office leadership, the department's design team, and our consultant liaison engineers. This will then be followed with a technical presentation of the design, which will include the condition of the existing structure, purpose and need of the project, and the recommended design solution, which has progressed to a 30% design completion. As part of the department's public outreach program, it is at this point that we are reaching out to you, the public, while it is still early in the design process, to receive any comments, concerns, and answer any questions you may have. We will also have a representative from the Office of Rights of Way to explain the rights of way process. And lastly, we will have a live question and answer session. I will now explain how you will be able to interact with the project team. There are three means of how you will be able to communicate. The first is by email, which is dotproject0-161-0143@ct.gov. And I'll also spell that out. It's dotproject0-161-0143@ct.gov. You can also phone in, and the phone number is 860-944-1111. Again, the phone number is 860-944-1111. Or you can also communicate by chat on the MS Teams live event chat. In this format, you can ask a question by clicking on the little question mark, which shows Q&A, and this will bring up your live event Q&A field. Select the Ask a Question button at the bottom right screen, and a field will pop up, and you can type your question and hit either Enter with a little arrow button to send, or you can also check the box on the bottom to post your question anonymously if you prefer. There will be a slight delay, but eventually your question will appear in the featured section with all other questions that are asked tonight. The project email, phone, and chat will be screened by the project team during the Q&A session, and the questions asked by any of these methods will be posted on the MS Teams Q&A chat window. The questions will be asked out loud for the project team to answer. You can ask the questions at any time during the presentation, but we will answer these during the live Q&A session that follows. We also have the project webpage link, where the recording of tonight's entire presentation, including the Q&A session, will be stored. The webpage will also contain the same information that I have previously explained on how to provide comments and ask questions. And that project webpage is portal.ct.gov/DOT Wilton 161-143. And I'll also spell that out. It is portal.ct.gov/DOT Wilton 161-143. And lastly, please remember the comment period to ask questions or provide comments will be open through November 26, 2020 via either email or telephone. So if you think of a question after tonight's meeting or want to expand on a question asked tonight, you will have till November 26th to do so. The MS Teams chat function is only available during tonight's live Q&A session. We would greatly appreciate it if you could fill out the demographic survey the department has through SurveyMonkey. This virtual public informational meeting platform is still a relatively new one for the department, and this survey will help the department improve these meetings going forward. There's also a civil rights flyer available. Both the links to the survey and civil rights flyer are located on the previously mentioned project webpage. And lastly, I am required to read the following statement as part of the Title VI Civil Rights Act, and that is, no person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. I would now like to explain how this project is being funded. This bridge is a town-owned bridge and is being funded under the department's Federal Local Bridge Program. Traditionally in this program, the town selects a designer, and because federal funds are involved, the department provides administrative oversight because the department is considered to be stewards of those federal funds. The funding is traditionally 80% federal and 20% town for the design, rights-of-way, and construction phases of the project. However, this project is going to be funded under the department's newly launched DMS, or Design Managed by the State program. In this program, it will be the department who will be performing the design on behalf of the municipality, utilizing our consultant liaison engineers, who in this case are Clough Harbor Associates, or CHA. CHA has completed the 30% preliminary design, and it will be brought to final design completion by one of our pre-selected task-based designers. In addition, the design phase will now be funded with 80% federal and 20% state funds, so the entire design phase is at zero cost to the town of Wilton. Although the 30% preliminary design was performed by the department, it was in full partnership and coordination with the town of Wilton. We held several meetings with the town and diligently worked together to incorporate most of the town's comments and concerns, and now we are reaching out to you, the community, to also weigh in. The department is extremely pleased to be able to offer this program to the town of Wilton. The DMS program is spending your municipal and state tax dollars both efficiently and effectively, and at the same time fostering great working relationships with our municipal partners. And now with that, I'll hand it over to Mr. Frank Smeriglio, Assistant Public Works Director for the town of Wilton.
My name is Frank Smeriglio. I am the Town Engineer and Assistant Director of Public Works for Wilton. I want to thank everyone for joining tonight. As Pretty said, our intentions for the meeting tonight are to provide you with preliminary information about the bridge replacement and to receive input from residents. I also want to give you a little background about Wilton Bridges and a brief description of how it translates into prioritizing the bridge on Arrowhead Road. There are 27 bridges in Wilton that fall into two categories. One category are bridges 20 feet in length and greater, and the second category are bridges that are between 6 feet and 20 feet in length. The bridges that are over 20 feet in length are generally inspected by the state DOT every 2 years. The bridges that are between 6 and 20 feet in length are generally inspected approximately once every 10 years. The inspection reports are given to the town as an initial starting point for the town to formulate a master plan. The bridge repairs are prioritized, and the bridge on Arrowhead Road is one of the bridges on top of the list. With all the bridges and various work needed on each, the town has to take advantage of state and federal grant programs to accomplish the work needed. For Arrowhead Road Bridge, this qualified and was approved for what's called the Federal Local Bridge Program. In this program, the federal government pays 80% of design and construction, and the town pays for 20% of construction. This grant is monitored by the state of Connecticut DOT. The state DOT also provided a supplemental program award for this bridge where they are partnering with the town to complete the design process. This program includes the state paying for the remaining 20% of design costs. The town are able to utilize their in-house engineers and on-call consultants to navigate this project through the different design concepts, different permit requirements, and then final design. So as we get into our presentation, we'll give you, our intentions are to give you general information, preliminary information about the bridge, and any input we receive from you would be greatly appreciated. Thank you.
Thank you, Frank. I would now like to introduce the project team. I am Preeti Bardwaj, the project manager shown in the center. To my left are the department's front office leadership, which includes Mr. Bart Sweeney, Division Chief of Bridges, and Mr. Robbie Barakat, Principal Engineer. To my right are Mr. Mark Burns, Project Engineer, and Mr. Dennis McDonald from the department's Rights of Way. The consultant liaison engineers who have brought this project to 30% design completion are Clough Harbor Associates, and from CHA we have Mr. Anand Shazadri, Project Manager, and Mr. Tom Lapata, Senior Design Engineer. So, ladies and gentlemen, we are finally ready to present our technical portion of the presentation, and you will be hearing a lot of bridge lingo throughout the presentation. Therefore, I am about to give you a 2-minute crash course on some of the structural elements on a bridge and the numerical condition rating system assigned on a bridge. On the diagram shown, the deck is the riding surface of a bridge. The parapets, or sometimes bridges can also have an open rail system, helps prevent errant vehicles from going off the bridge. The beams, or the girders, are the supporting structural elements on the bridge and are designed to support vehicular loads and the self-weight of the bridge and any environmental loads such as wind, seismic, etc. The parapets, the deck, and the beams are what is known as the superstructure on a bridge. The abutments and the wing walls are the end supports on the bridge, and piers, if there are any, are the intermediate supports. The abutments, the wing walls, and the piers, if there are any, make up what is known as the substructure of a bridge. The substructure not only supports the superstructure, but also helps in transmitting loads from the superstructure down to the bridge foundations. All state bridges and town bridges over 20 feet in length are inspected every 2 years by the department's Bridge Safety and Evaluation Unit and are assigned a condition rating on its major elements on a scale of 1 through 9. with 9 being excellent condition and 1 being imminent failure condition. When a major bridge element reaches a 4 or poor condition, that is when we start to initiate a project to address the structural deficiencies. Now that you are armed with basic bridge knowledge, I would now like to introduce Mr. Tom Lapata from CHA, who will be presenting the technical portion of the presentation.
Thank you, Preeti, and welcome everyone. As mentioned, I will be discussing the technical portion of tonight's presentation for project number 161-143, replacement of bridge number 5501, Arrowhead Road over the Norwalk River. On the screen is an aerial view of Wilton in the vicinity of the project. Arrowhead Road is located off of Route 7, Danbury Road. Arrowhead Road crosses over the Norwalk River via bridge 5501, and that's circled here in red. West of the river, the road continues to a cul-de-sac, and beyond the river are approximately 10 residential properties. The properties on the north and south side of the bridge cross over the river and are 16 Arrowhead Road on the north and 23 Arrowhead Road to the south, with both of the houses approximately 40 feet offset from the edge of the existing road. Beyond the roadway itself is the Metro North commuter rail, which runs north to south, but there is no formal access to the tracks from Arrowhead Road. Bridge 5501 was built in 1985, replacing the existing wooden deck and stone masonry structure that preceded it. The average daily traffic, or ADT, for Arrowhead Road is estimated to be 70 vehicles per day, and is also classified as an urban local road. The bridge has a span length of about 60 feet and a curb-to-curb width, or drivable width, of approximately 23 feet 7 inches. There's a wooded picketed fence located at all 4 corners of the bridge. While the bridge does not contain any utilities on it, there are overhead utility wires and poles that span across the river on the north side of the bridge or upstream side of the bridge. And you can see the poles here and here. Here is a section view of the existing bridge superstructure. As mentioned, the curb-to-curb width is 23 foot 7 inches, and the out-to-out width, or the total width of the bridge, is 29 feet 11 inches. The bridge superstructure is comprised of a paved orthotropic steel deck that is supported by steel floor beams. So here's the deck and the floor beams below it. The floor beams run perpendicular to the roadway and frame into the triple stacked truss panels that run parallel to the roadway and carry all of the bridge's self-weight and traffic loads. Since there are only 2 truss panels on this bridge, the bridge is considered to be fracture critical because there is no redundancy if one of these truss panels fail, which is in contrast to a bridge that typically has multiple redundant girders below it. In addition to the truss panels being fracture critical, they also serve as a barrier to contain vehicles traveling across the bridge. Here we have an elevation view looking upstream at the bridge from its south side. As mentioned, the total span length is approximately 60 feet long. Along the roadway, we can see that wooden fence at the approaches as well. Below the superstructure, the bridge is supported by its substructure, which consists of a concrete pile cap with steel H piles driven into the ground below it on both sides. Below the bridge, we can see the stone masonry abutments from the previous bridge, which these stone masonry abutments now serve as scour walls for the new bridge. From a hydraulic standpoint, the 100-year and 500-year storms do not pass underneath the bridge. Those are both located here. passing through the actual truss superstructure itself, whose low chord is at elevation 139.5. So now that we've seen some sketches of the existing bridge, let's take a look at some actual site photos. The photo on the left is the north elevation of the bridge, looking downstream. We can see the stone masonry abutments below the bridge on both sides. The photo on the right is the south elevation of the bridge looking upstream, and that view matches the sketch that we saw in the previous slide. At the east approach to the bridge, the photo shown on the left, we can see the heavy vegetation that surrounds the roadway. We can also see the utility poles that run along the north side of the bridge, and we can also see the roadway climbs up to meet the top of the bridge. At the west approach, we can see the flat profile of the bridge at the top, along with the wooden fence at the approach, and again, the utility poles on the north side of the bridge. As Pretty mentioned earlier, bridges inspected by the state are given condition ratings on their various elements. Photos of the top and underside of the deck are shown here on the left and right respectively. The overall condition of the deck, which is comprised of the overlay, the steel deck, and the steel curbing, is rated a 4 or is in poor condition due to the heavy rust present on the underside of the steel deck shown in the photo to the right. There is no formal bridge rail system here. The triple stacked trusses act as the bridge's rail system and do not meet the minimum standards. We can see these trusses in the photo to the left acting as a barrier for preventing errant traffic from running off the side of the bridge. If a vehicle were to strike the truss, however, it may compromise the structural integrity of the entire bridge should that truss become damaged. Although the overlay is rated a 7 or is in good condition, the rating of the deck structure item governs the overall rating of the deck condition and is therefore poor or rated a 4. The overall condition of the superstructure, which is comprised of the galvanized steel plate bearings, floor beams, and trusses, is rated a 4 and is in poor condition, and that is again due to the condition of the steel floor beams. We can see heavy rust that surrounds the floor beams due to water leakage through the deck above it. Although the trusses are in good condition, as shown in the photo to the left, the lowest rated element determines the overall condition rating of the superstructure here, which again is poor, rated a 4 due to the condition of the floor beams. Moving below the bridge to the substructure, the overall rating, which consists of the abutments, footings, wing walls, and scour, is rated a 7 good. This bridge does not currently have any footings or wing walls as part of its substructure, and that's why the N is noted here in this table. At the top of the west abutment, we can see the concrete pile cap of the bridge where the bearings rest. Beyond the bearings, the bridge deck spans approximately 3 feet and rests on a concrete block back wall, shown in the photo at the bottom right. Below the concrete pile caps, again, is the stone masonry abutments, which aid in preventing scour from the flowing river, which is rated an 8, very good. Moving on to the condition of the upstream and downstream channel, the overall condition is rated a 6, satisfactory, with no noteworthy deficiencies. We can see the river is relatively shallow with cobbles and boulders within the stream bed and large boulders lining the edge of the channel on the downstream side. So given what has been shown of the existing bridge, there are several deficiencies that need to be addressed. The existing curb-to-curb width of 23'7" is slightly less than the state standard width of 24 feet, which is the required curb-to-curb width for an urban local road. That's shown down here in the table. Additionally, the existing roadway is approximately 24 feet at the bridge approaches as well, so this 24-foot curb width would match that. While federal highway requires a minimum of 18 feet curb-to-curb width for this particular roadway, which has an ADT of 70 vehicles per day. The town standards require a minimum curb-to-curb width of 22 feet for Arrowhead Road, which is classified as a secondary roadway, shown in the table at the bottom right. As mentioned before, there's no formal grid rail system, with the trusses themselves serving as protection. Again, that is undesirable, because if it gets struck, then it can compromise the structural integrity of the bridge. The steel deck and floor beams are in poor condition, resulting in the bridge being classified as structurally deficient and therefore in need of repairs. The trusses themselves are fracture critical, and that they do not provide any redundancy to the bridge's ability to carry loads. While a judgment rating of 34 tons has been assigned to this bridge, there's no documented load rating of this bridge to assess its actual load carrying capacity. In regards to the substructure, the design for it is for the specific bridge currently on Arrowhead Road, and those concrete pile caps cannot be reused for any type of superstructure replacement, trying to utilize this existing substructure. And lastly, the existing bridge does not pass the 100-year design storm for the Norwalk River. So with all those previous deficiencies mentioned, a full bridge replacement is the only option here to address all of those concerns. The new bridge would have a 24-foot wide curb-to-curb roadway width, which would meet Connecticut standards. However, as shown in the previous slide, the town may elect to go with a 22-foot wide curb-to-curb bridge, which would satisfy their town standards for a secondary road. The new bridge rail or parapet system would be crash tested and meet the required safety standards. The wooden fence at the approaches of the current bridge would be replaced with much stronger timber guide rail. The new superstructure itself, which would look similar to what's shown on the photo to the bottom right on its underside. It's precast concrete deck panels, which are much shallower than the existing truss structure, which allows for the low chord of the bridge to be higher than the existing and helps aid in passing the 100-year design storm below the new bridge. And lastly, these shallow precast concrete deck panels also help in maintaining the existing top of roadway of Arrowhead Road, which minimizes any full depth roadway reconstruction at the approaches. Moving on to some details of the proposed bridge. Here we have a section view of the superstructure. As we can see, the bridge has been slightly widened to afford that 24-foot wide curb-to-curb width, which consists of two 10-foot lanes and two 2-foot shoulders. The travelway over the bridge will be protected by an open bridge rail system that's mounted onto concrete curbs. And as mentioned, the superstructure is comprised of 7 precast concrete deck units that are all linked together with ultra high performance concrete shear keys. So this type of superstructure, again, allows for a much shallower thickness or superstructure depth than the previous bridge, which again helps in passing the design storms below it and maintaining the top of the existing roadway elevation as much as possible. Moving on to the plan and elevation view of the new bridge, color coding will more easily show the various components of the proposed bridge and roadway. In orange, we can see the limits of the proposed superstructure, which has a new span length of 51 feet. The superstructure is supported by new cast-in-place abutments and wing walls, shown in gray, which are supported by steel piles below it, driven down to bedrock. The piles address the potential for future scour concerns and also allow for a semi-integral connection that eliminates bridge deck joints and minimizes future maintenance of the bridge. Aesthetically, the bridge will feature a metal open bridge rail system with simulated stone concrete end blocks, also known as form liner, at each corner of the bridge. The new bridge will have a higher lower chord and will continue passing the 50-year design storms and will now pass the 100-year design storm as well. The full depth roadway reconstruction at the approaches, shown in yellow, will require regrading along its side slopes, which is shown here in green. Pink represents the bridge approach guide rail at all four corners of the bridge. Lastly, below the bridge, the dark blue represents the limits of the watercourse, and the cyan represents the regulated wetlands. Zooming out a bit, we have a highway plan of the project limits with the roadway reconstruction extending approximately 125 feet, both to the east and west of the bridge. The new bridge will require a vertical adjustment of the roadway profile in order to adequately fit the new bridge in place, and thus the extended roadway limits here shown in yellow. This will help transition the bridge smoothly back into the existing roadway profile. The approach guide rail, again, will extend approximately 75 feet beyond the bridge at all four corners. Additionally, the driveway at 16 Arrowhead Road to the northwest of the bridge will require regrading as it falls within the limits of the roadway reconstruction, and that regrading is shown in light orange. Lastly, the limits of the town's right-of-way and individual property lines are shown within the dashed red lines along the roadway. All of the completed work is anticipated to remain within the town's right-of-way along the roadway. As mentioned, the new bridge will require an adjustment to the existing roadway profile in order to fit the new bridge and transition smoothly back into the existing roadway. So this brown shown here represents a cut where the existing roadway is cut back and regraded to the new limits here shown in yellow, as well as the thickness of the bridge itself here shown in orange. And again, lastly, we can see in this profile view the 100-year design storm passing below the new structure, which is an improvement from the existing bridge. So far, we've mostly been talking about the proposed bridge itself, but let's take a few moments to discuss how traffic will be handled during construction. As mentioned earlier, because this bridge is a truss, it does not offer any redundancy with each panel on both sides of the bring all of its self-weight as well as all traffic loads. Should one of these panels either fail or become disconnected during construction, it would result in the bridge becoming unstable. In the preliminary engineering phase, a typical stage construction approach was considered, which is shown here on the slide. However, it did prove to be complicated and required a temporary beam be installed on the top of the bridge, connecting down to the floor beams so that the bridge can be replaced in stages. Stage one would have traffic on the north side of the bridge in a one-way alternating pattern using temporary signalization, while the south side would be demolished and replaced with a new bridge shown in cross-section 2. This second stage shown here would then be able to handle traffic, while the remaining portion of bridge on the north side would then be demolished and replaced, joining with the new portion of bridge shown in the final cross-section here. The problem with using the temporary beam is that it needs to be connected to the floor beams, which are in poor condition as shown in the photo to the right, and is the principal reason why this project was initiated to replace this bridge. The floor beams may not be able to handle the new connection to the temporary beam given their poor condition, and if the connection cannot be made adequately, the staged approach would need to be abandoned by the contractor, and a temporary bridge would be required on short notice, further delaying construction. Ultimately, the temporary bridge is the option that was pursued in the preliminary engineering phase for handling traffic, and will be outlined in the next few slides. Two last points on the staging approach and why it is less desirable is that it will also take longer to construct using it because of the two discrete stages, and traffic will be right up against the contractor's work zone during the stage construction, resulting in less work zone safety. As the previous slides demonstrated, the stage construction approach is not desirable, and a temporary bridge would be the best option or handling traffic during construction. Here we have a plan view of the temporary bridge shown in orange, placing it on the upstream side of the existing bridge in order for its temporary roadway approaches shown in yellow to better tie in with the existing roadway, which immediately turns to the south, west of the bridge, shown in gray. Purple barrier is shown south of the temporary bridge. This will establish a safe work zone for the contractor to replace the existing bridge quickly and further away from the traveling public. The temporary bridge will have a span length of approximately 90 feet and may require temporary fill and a temporary earth retaining system at the steep approach to the east, shown in green and brown respectively. The temporary bridge will be 1 lane wide and allow for alternating one-way traffic using temporary signalization lights at each end, similar to what is shown in the photo to the right. If you remember the photo at the approaches earlier in the presentation, the vertical curve over the bridge and the horizontal curve to the west of the bridge would make it difficult to see oncoming traffic. Therefore, the temporary signalization will safely allow vehicles to know when to cross. So similar to the proposed bridge, we have a temporary bridge profile view here. The temporary bridge shown in orange, along with its temporary roadway approaches shown in yellow, with brown above that representing some grading that would need to be done in order to get those temporary approaches to fit adequately back into the roadway. Over to the right of the temporary bridge in dark red is the temporary earth retaining system that we saw on the previous slide. And that essentially helps eliminate the overall span length that would be needed for the temporary bridge. Here we have some photos of some temporary bridges. Traditionally, 2 different styles are utilized. The photos on the left represent a stick-built style with individual girder lines and a deck placed atop it, or even pairs of girders that are joined with a deck already that are placed modularly adjacent to one another. Whereas the photo on the right represents a through truss style bridge, commonly known as an acro bridge, which interestingly enough is the style of bridge that we are currently replacing under this project. But both of these can be used as a temporary bridge, and ultimately the contractor that is selected to do the bridge replacement project will determine which bridge works best for this site. While we have so far discussed the technical aspects of the new bridge, let's take a moment to discuss its aesthetics as well. The bridge will feature an open metal bridge rail system with concrete end blocks at each end, similar to what's shown in the photo at the top. These end blocks will feature simulated stone masonry, also known as concrete form lining, and the color of the bridge rail as well will be the choice of the town at a later date in the design process. Connecting the end blocks will be timber guide rail that will extend from the bridge along the roadway approaches, similar to what is shown in the photo at the bottom. And lastly, for an additional cost to the town may elect to pursue real stone masonry veneer on the faces of the concrete end blocks, similar to what's shown in the 2 photos on this slide. The actual stone pattern will be the town's liking and coordinated at a later date during the design process. Moving on to some utility and environmental impacts. Again, there are overhead wires and poles on the north side of the bridge. In order to remove and replace the existing bridge, as well as install the temporary bridge, these utility poles and wires will need to be relocated to the south outside of the construction area. From an environmental standpoint, there will be impacts within the wetlands and potentially within the water course for the construction of both the new and the temporary bridges. Because large equipment is required to lift the precast concrete deck units, as well as drive the piles below the substructure for the new bridge, trees that are overhanging the road on both sides will need to be trimmed or cut as required for construction. Here we have a plan view depicting the temporary impacts beyond the rights-of-way. What we're showing is the permanent work of the new bridge overlaid with the temporary bridge atop it. And that shows both limits of impacts, with the temporary bridge obviously being temporary, and the red hatching or shading here indicating the area that would be needed under a temporary construction easement. That temporary construction easement would be required at both 16 Arrowhead to the north and 23 Arrowhead to the south, which again will help in having room for the contractor to install and utilize a temporary bridge to the north, as well as some grading operations along the roadway to the south. Please note that these temporary construction easements are indeed temporary, and that these areas here will be restored to their original conditions when construction is completed. Before I wrap up my portion of this presentation, I wanted to provide a brief overview of the anticipated costs and construction schedule. Currently, the project is expected to begin construction in the spring of 2023 and finish in the fall of 2023. The anticipated construction costs is $3 million, with 80% of the construction costs being federally funded and 20% being covered by the town under this federal local program. Please note that the costs and the schedule are preliminary and subject to change. With that said, thank you for listening, and at this time I'd like to hand it over to Dennis McDonald of the Rights-of-Way Union.
Good evening, everyone. My name is Dennis McDonald, and I'm a representative from the Connecticut Department of Transportation, Division of Rights-of-Way. Tonight, I will provide a brief overview of the right-of-way process. Please note the town of Wilton has asked the DOT to take the lead in terms of right-of-way activities for this project, and DOT will work in concert with the town of Wilton and Frank Vermiglio to successfully accomplish project goals. That being said, let's discuss the right-of-way process. So the function of the Division of Rights-of-Way is to acquire all property and property rights necessary for the project. This is done in accordance with Connecticut General Statute Section 13A73, 13A98E, as well as the Uniform Relocation Assistance and Real Property Acquisition Policies Act of 1970 as amended. Typical property impacts include partial acquisitions, easements, and rights. Property impacts will be refined and are subject to change as the design progresses. Once property impacts have been determined, each impacted property owner will receive a letter of intent to acquire, along with a property acquisition map. The letter essentially initiates the right-of-way process, and the map provides a detailed breakdown of the specific property impacts. Soon after the letter and map are received, a valuation process will take place, and once a value has been established, each impacted property owner will receive a written offer of compensation. Property owners will be given time to consider the offer and negotiate should they wish. If an agreement is reached, an acceptance document is signed and a closing will take place at a later date. If an agreement cannot be reached for whatever reason, the state will utilize its power of eminent domain and acquire the property rights through the condemnation process. Now, I understand this has a negative connotation, but many times this is done to keep a project on schedule. If the state does elect to pursue eminent domain, the original offer is deposited in the court system available for withdrawal, and property owners can continue negotiations or file a formal appeal for a reassessment of damages through the court system. Please note, all appeals must be filed within 6 months from the date in which the state files for eminent domain. And that's essentially the right-of-way process in a nutshell. Thank you for your time tonight.
Thank you very much, Dennis. And that, ladies and gentlemen, concludes our technical portion of the presentation. I would like to thank everyone on my design team and everyone behind the scenes who helped put this live event together. We are going to leave the Q&A session information on the screen for your benefit, and we will be answering any questions that came in during the presentation and answer any questions that will come in during this live Q&A session. Once again, we would like to remind everyone to please visit the project webpage to participate in the survey pertaining to tonight's event, or ask additional questions, or view project plans and information. For those of you listening on the phone, the project web page is again portal.ct.gov/DOT Wilton 161-143. So with that, we are now going to take as many questions as we can and start the live question and answer session. Feel free to use that chat feature or call in by telephone. The number is again 860-944-1111, or by email. The address is again dotproject0161-0143@ct.gov. And once again, the comment period is November 26th, 2020.
Okay, ladies and gentlemen, it looks like we have quite a few questions in the live event Q&A chat box, and I will start the first question that's been asked. The question is, has the town secured their share of the funding? And can I please have Frank, the Assistant Public Works Director from the town of Wilton, please take that question.
Hi, this is Frank Smirglio from the town of Wilton. Yes, we have secured our 20% funding for our portion of the project.
Okay, thank you very much, Frank. Next question. When is construction anticipated to start and when will it be completed? Tom from CHA, can you please take that question?
Thank you, Pretty. This is Tom from CHA. And to answer your question, construction is anticipated to start in the spring of 2023 and end in the fall of 2023, essentially one construction season.
Okay, thank you very much, Tom. Next question. If the construction takes longer than one season, will the temporary bridge stay up during the winter? Tom from CHA.
Thanks, Pretty. Yes, to answer your question, if the construction takes longer than one season, the temporary bridge will remain through the winter, but it's anticipated that given the amount of time we have, that isn't likely. However, if it does require an additional time beyond one season, the contractor will work as much as he can through the winter to get as much work done as possible. And should the weather become adverse, there may be a temporary pause, and as soon as the weather clears up, the contractor will be back out there immediately to finish the job. But ultimately, we expect this to take one construction season and not require a winter work or a work in the following year.
Okay, thank you very much, Tom. Next question. How wide will the temporary bridge be? And will it be able to handle heavy vehicle loads? Tom, can you please take this question?
Sure. So the temporary bridge is anticipated to be 12 feet wide, which is typically the width we want for one lane of vehicle passing over the bridge, since it is a one-way alternating bridge. The 12-foot wide temporary bridge will be able to handle all legal and live loads that are generally permitted to drive on state roads or any other roads throughout the town. So no issues anticipated with what the temporary bridge can carry from a loading standpoint.
Okay, thank you very much, Tom. We have another question. Where will the contractor place his equipment? Tom from CHA, can you please take that question?
Sure, Pretty. Let me actually pull up the slide that shows the temporary bridge. Okay, so here we can see the location of the temporary bridge on the north side, or the upstream side of the existing bridge, and the purple barrier represents the concrete barrier that would sort of cordon off the work zone for the contractor, which would be confined generally inside this area, away from the temporary bridge, and the temporary roadway approach is shown in yellow and orange. So generally, we'd expect the contractor to store his equipment and materials within this area throughout the duration of construction.
Okay, very good. Thank you, Tom. We have another question. What environmental permits are anticipated? Tom?
Yeah, pretty, I can answer that. For this project, we're anticipating a flood management memorandum of understanding, in addition to an Army Corps self-verification form. And lastly, local inland wetland general permits from the town of Wilton, Wetlands and Watercourse Commission. So we'll be coordinating with all three of those different entities throughout the design process to secure permits for this project.
Okay, thank you very much. We have another question. How much higher will the highest point of the new bridge be versus the existing bridge? Tom from CHA.
In regards to the proposed bridge and the existing bridge, let me actually pull up the profile view. So we're showing here on this screen the orange showing the proposed bridge and the dashed line showing the existing bridge. So it's generally within a few inches of the existing roadway surface over the bridge. We are trying to lay out geometrically a nice curve across the bridge. So the existing bridge is flat with some slopes beyond it on each side. So this geometric curve helps better fit and increase the rideability over the bridge. So that's sort of where this profile was developed here. But to answer the question more straightforward, a few inches would be the raising of the new bridge compared to the existing.
Okay, thank you very much, Tom. So we don't have any questions through the chat or through any other means right now. So we'll just give it another minute. So ladies and gentlemen, while we are waiting for a question, I would like to remind you that this whole presentation, including the Q&A session, will be recorded and will be posted to YouTube following the event, and closed captioning will be made available at that time. The recording will also be made available on the list of virtual public meetings on the link shown on the project webpage. I don't see any other questions coming in. Just give it a few more seconds in case anyone is typing slowly. Okay, I think I am going to start the wrap up. Oh, wait, I see a question came in. Okay, question is, what aesthetic treatments are proposed? Tom from CHA?
So this is Frank from the town of Wilton. On the plans, as part of the grant, the grant award covers the cost of concrete, and there's some pictures up before it was called form liner. But again, the town is looking to put stone on some of the what's called the end blocks that are in corners of the bridge. And we're also looking at some potential stone work on other areas too. And then again, with the guardrails
We're looking for a wood type guardrail, probably metal post similar to the Merritt Parkway guardrail. And then the railing on the bridge, with the railing on the bridge, we're looking for a metal type rail, similar to what's in the picture. Color to be determined, and again with the railing, it has to meet a certain crash criteria for that. I don't know if Tom, you have anything else to add with this?
No, I think that covers it pretty well. Thank you, Frank.
Okay, thank you very much, Frank and Tom. So, ladies and gentlemen, it looks like we are not receiving any more questions. So I'm going to take this opportunity to start wrapping up. Before I do, I would like to encourage you to take that brief survey. The link is shown in the chat box. We would very much appreciate it if you would do that. This really helps us improve this virtual meeting experience in the future. Once again, ladies and gentlemen, on behalf of the department and the town of Wilton, I would like to thank you for joining us tonight for this virtual public informational meeting for project 161-143. And we hope that you found this meeting and presentation to be informative. All of us on the design team and the town of Wilton are always available to answer any questions, even outside of the comment period. We are also available to meet with you individually on the project site if you so desire. Thank you once again and have a wonderful evening.
And just one more thing to add, this is Frank from the town of Wilton. Again, I want to thank everyone for joining. As much input as you can give us would be much appreciated. And also my office is just down the street at Town Hall. Feel free to call me with any questions. Thank you.
Thank you very much. Have a good evening, everyone.